Hello future engineers, welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends. That's one way you can keep me going, inspired and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe.
Level 165, for a given area, the moments of inertia with respect to two rectangular x and y axes are I barred x 1200 inches to the fourth and I barred y equals 300 inches to the fourth respectively. Knowing that after rotating the x and the y axis about the centroid 30 degrees counterclockwise, the moment of inertia relative to the rotated x-axis is 1450 inches to the fourth. So use Mohr circle to determine the orientation of the principal axis and be the principal moments of inertia. So take note that when the x-axis is rotated 30 degrees counterclockwise, the moment of inertia has increased to 1450. So if you're going to analyze this problem, the product of inertia, which is the partner of I barred x, should be negative. So if we're going to analyze, and it should be somewhere here. So we have 1200 pxy, and p product of inertia xy is negative, and it should be smaller than the radius of the Mohr circle. The other one is 1000. The other one is 300. So assuming its graduation here is 200 inches to the fourth, so 300 is somewhere here, and the partner is positive pxy. So connecting these 2 points, it is the diameter of the circle. So since moment of inertia should not be negative even if it is the minimum, so this is the possible Mohr circle. We anticipate that product of inertia partner of 1200 xy is negative. So if we rotate, if we locate the center, which is the average of 1200 and 300, so that's the centroidal x-axis, this is the centroidal y-axis, and this is the center, which is the average of 1200 and 300. So one half of quantity 1200 plus 300 is 750. So the radius should be slightly smaller than 750. So that's why this angle here should be less than 60 degrees. Because if it is more than 60 degrees, then after rotating, then there's a possibility that this circle will cross this product of inertia axis, which should not be the case because it should have a minimum positive value of moment of inertia. So this is most probably the circle, and rotating this x-axis, centroidal x-axis, 30 degrees counterclockwise in the Mohr circle, that will be 2 times 30, and it is 60 degrees as shown. So this, we will call this the u-axis, and the value of I sub u is equal to 1450. So that's the possible position because I barred x is 1200 and it increases, so that means it should surpass, or the rotation should be passing the principal axis I1, which is the maximum, and this is I2, the minimum. So this is 60 degrees, and the angle that the u-axis makes with the principal axis I1, we will call that alpha. So the radius is r, that is also r, and we will call that alpha. So that the value of I sub u is 1450, and from the figure 1450 is equal to 750, the moment of inertia here, 750 plus the projection of r upon the principal axis is this projection of the right triangle hypotenuse r cosine of alpha. So the first equation should be 1450 equals 750 plus r cosine of alpha. Simplifying this equation, we establish the first equation, r cosine alpha equals 700. Call that equation 1. For the second one, let's set up this equation 1200. And imagine we have a right triangle here, and the angle that this radius makes with the principal axis, one principal axis, is 60 degrees minus alpha. So therefore, 1200 is equal to 750 plus the horizontal projection of this right triangle with radius big R. It is 1200 equals 750 plus R cosine of quantity 60 degrees minus alpha. So 1200 equals 750 plus R cosine of 60 degrees minus alpha. Simplifying, 450 equals R cosine of 60 degrees minus alpha. We then eliminate R by dividing equation 1 by equation 2 by equation 1. So 450 divided by 700 equals quantity R cosine quantity 60 degrees minus alpha over R cosine alpha. So we cancel R, then simplify this. This is equal to 9 over 14 equals cosine of quantity 60 degrees minus alpha over cosine of alpha. You may expand cosine of 60 degrees minus alpha, which is cosine 60 cosine of alpha plus sine 60 sine alpha. But since the calculator is capable of solving equation, this one, by natural display, so we'll just do that, and we set alpha to be about 10 degrees or 15 degrees from this figure. So alpha equals 9.367 degrees from the calculator, which is allowed. And therefore, we can now solve for R. Substitute into equation 1, R cosine of 9.367 degrees equals 700. So R is equal to 709.46 inches to the fourth. Having found R, then we can now set up, because this angle is 2 times theta 1. This is the principal axis. Call that 2 theta 1. After we solve for theta 1, the angle spacing between the principal axis, this is theta 1, and in the Mohr circle, it is doubled. This is the other axis. They are 180 degrees apart from this Mohr circle. So from this axis to this axis here, 180 degrees, but in the actual configuration, actual situation, it is just 90 degrees. So after we find theta 1, which is counterclockwise in this case, and that's the positive sense by sign convention, then we simply locate the other principal axis I2, or the angle is theta 2, as theta 1 plus 90 degrees. So 2 theta 1 equals 60 degrees minus alpha from the figure, this angle here. So theta 1 can now be solved. It is equal to 25.32 degrees. Then theta 2, as I said, you just add 90 degrees, so it is 115.32 degrees. So 115.32 degrees. That's the orientation of the principal axis. The principal moments of inertia are namely I1, which is here, maximum, and it is just 750. Then we add the radius. It is the extreme rightmost point. So it is equal to 750 plus the radius, while the minimum moment of inertia, I2, this one, is simply 750, then minus the radius. So that's I2, or I2 minimum. So I1, which is I max, is equal to 750 plus radius 709.46. So I1, which is equal to I max, is equal to 1459.5 inches to the fourth, while I2 is 750 minus the radius, or I minimum. So I2 or I minimum is equal to 40.54 inches to the fourth. So that's it for this problem. This is a challenging one, and I hope that you were able to follow the solution and the explanations. Level 166, determine the principal moments of inertia and the principal directions at the centroid of the region shown. So first, for the solution, let's divide the figure into two rectangles. So from here, so the area of this part is 2 times 6, so 12 inches square, while this one is 4 by 2, so 8 square inches. This is the location of the centroid, which is 1 from the y-axis and 3 from the x-axis, as shown. Then the centroid of this area is, because this is 4 inches, so 2 plus 2, 4 from the y-axis and 1 from the x-axis. So by Varignon's theorem, so let's locate the centroid and denote it as, we imagine that the location of the centroid is at C, and the coordinates are x sub c and y sub c. So that by Varignon's theorem, 12 plus 8 is 20, the total area. 20 times x sub c equals 12 times 1 plus 8 times 4. So x sub c is equal to 2.2 inches. Then if we divide for the second part, 20 times y sub c equals 12 times 3 plus 8 times 1. So the value of y sub c is also 2.2 inches. Then, to solve for the centroidal moment of inertia, there are two ways, but we'll just first compute Ix, then Iy. Ix is moment of inertia of this rectangle with respect to the base, because the x-axis coincides with its base. And for this rectangle here, the base also coincides with the base. And the moment of inertia of a rectangle with respect to the base is base height cube over 3. So therefore, it is, for this rectangle, 2 times 6 cube over 3. And for this rectangle, plus 4 times 2 cube over 3. So Ix is equal to 464 over 3 inches to the fourth. Likewise, if we divide the area horizontally from this corner here, then we have 4 inches by 2 inches. The moment of inertia with respect to the y-axis is 2, the same, 4 times 2 cube over 3, which is this. Then for this rectangle here, because if we imagine we divide it this way, horizontally, the base is, which is coincident with the y-axis, is 2, and the height is 6, so it is 2 6 cube over 3. We expect that Iy is also equal to 464 over 3. Then by definition, Ix equals centroidal moment of inertia with respect to the x-axis plus area times barred y square, or y sub c square. Remember, Ix equals moment of inertia with respect to the centroidal x-axis plus area barred y square. Since barred x and barred y are the same, denoted by respectively here by 2 by x sub c and y sub c respectively. So therefore, I sub cx is equal to 57.87 inches to the fourth. Iy is the same as I said, because it is 2 times 6 cube over 3. If we divide for this rectangle here, this is 2. The height perpendicular to the y-axis is 6, so 2 times 6 cube over 3. And for this rectangle, the base, which is 4 inches, coincides with the y-axis, so 4 times 2 cube over 3. So it is equal to 464 over 3. Therefore, I sub cy is also 57.87. Then for product of inertia with respect to xy axis first, and we'll use transfer formula later, which is pxy equals p sub cxy, or product of inertia with respect to the centroid, plus area barred x barred y. Now, since each rectangle, component rectangle, is a shape of with two axes of symmetry, moment of inertia with respect to the centroid is 0. So therefore, the part which has value would be area barred x barred y. So pxy equals 12, barred x is 3, 1, sorry, barred y is 3. Then with respect to the centroid, 0. For this rectangle here, with respect to the centroid, 0 also. Remember the transfer formula. Product of inertia with respect to any axis is equal to centroidal product of inertia, which is 0 if it has at least one axis of symmetry, so 0, then plus area barred x barred y. So therefore, for this rectangle, it is plus 8 times barred x 4 barred y 1. So 0 plus 8, 4 times 1. So pxy is equal to 68 inches to the fourth. Then, by transfer formula, pxy equals p sub cxy plus area barred x barred y. And barred x is x sub c, barred y is y sub c also. Therefore, p sub c xy equals pxy 68 minus area 20, x sub c 2.2, y sub c 2.2. So product of inertia with respect to the centroid is equal to uh, negative 28.80 inches to the fourth. We then plot ICX, which is 57.87. The partner is P sub CXY negative 28.8. And the other one is I sub CY, which is the same 57.87, comma, the negative of this value, so it is positive 28.8. So therefore, 57.87 would be somewhere here. Assume that its graduation is 10 inches to the fourth. So 10, 20, 30, 40, 50, 7.87, and this is negative 28.8. Then the other part is overhead above because the same I sub cx equals I sub cy. There, it 57.87, 28.8. Therefore, if we draw the circle, we conclude that this 28.8 is the radius of this Mohr circle. So this is the first point plotted, which is x sub c. This is the second, the other end of the diameter y sub c. Therefore, to locate the principal axis from this centroidal x-axis here, we rotate counterclockwise 90 degrees, but the actual position would be half of 90 degrees, which is 45 degrees. So this is 90 degrees or 2 times 45 degrees, and therefore this is the principal axis from the other axis. From the x-axis, we rotate counterclockwise. So this is theta 1, and theta 2 is simply theta 1 plus 90 degrees in this figure. So where theta 1, since that's the maximum, this is the principal axis I1. So that's I sub 1 from the figure. Then this is I sub 2, the minimum, I sub 2. So rotating from the centroidal x-axis counterclockwise 90 degrees, we can locate the principal axis. Then we denote the angle as theta 1. So 2 theta 1 equals 90 degrees. And by the way, as mentioned earlier, the 28.8 pxy is the radius because it starts here and it ends there. And remember, by principle, that's the diameter of the Mohr circle. Therefore, 28.8 is the radius. So this is 2 theta 1 equals 90 degrees. As mentioned earlier, theta 1 therefore is 45 degrees. Since that's counterclockwise, that's just made positive. And theta 2 plus 90 degrees, so 135 degrees. So that's it for the principal directions. Then for the principal moments of inertia, since this is also the radius, and the center is 57.87, we just add R for I1 or I max. So 57.87 plus R 28.8, I1 therefore is equal to 86.67 inches to the fourth, and I2, which is here, which is 57.87 minus radius. So I2 is 57.87 minus 28.8, so I sub 2 is equal to 29.07 inches to the fourth. So that's it for this final problem on moments of inertia and part PT2. The next part would be part PT3 and it is on mass moments of inertia.